All right, welcome everyone. This is going to be a talk on preparing for smart contract audits. I'm going to keep this kind of broad because people here at Filecoin aren't just building on Solidity or smart contracts, but might be building in a variety of cases where they're engaging with a smart contract audit firm. So the first thing is just to talk about why audit preparation is important and why generally security is important. It's a lot of projects, or it's very critical that you get a smart contract audit or you get like a security audit or some third-party review, especially if you're launching an asset or protocol that's going to have assets at risk. But security doesn't just start there. You have to do it very early on. There's a full life cycle back when you start planning, you start coding, you start building and testing. And really, where audits actually come in this process is at that release stage, right prior to deploying your actual code. It's usually one of the last things you're doing. You're getting some expert opinions from folks, and you hope that the result is that you're going to have production-ready code where any potential issues your team might not have been able to catch on your own have been caught. There's also other versions of this, like getting a code competition or kind of having a pre-bug bounty. But security audits from like reputable firm like OpenZeppelin or many others in the industry is usually the go-to because you usually have an assurance that they'll get full coverage on your code, and you'll generally be, you'll work with them in the fixed review process to actually make sure that if there are any issues caught, they are addressed and that the code itself is secure at the end of that process, or is as secure as can be possible, because even these are not guarantees, which is all the more reason to have as many stages as possible. On the right side, we can talk a lot about like deployment and monitoring and operational practices, but we're going to really focus more on the left side, everything you should do leading up to a smart contract audit. I'll go ahead and preface this with saying I did commit one of the cardinal sins of PowerPoints, which is adding a lot of text, but what I'm really going to do is just briefly go over the text, which just really describes what you should do at every phase, but more talk about why this will impact the audit that you eventually get. And why it makes a big difference in the net result of your audit, because ultimately your security auditors are not your security team, and there's a lot that needs to be done ahead of an audit for it to actually be successful. And by successful, I mean the code that comes out of that audit is as production ready as possible, and there's a lot that has to be done prior. So talking a little bit more about really a lot of this I already went over, but what are audits supposed to do? They're supposed to detect and fix errors in the code. That's one of the first and most obvious things. But there's also a general expectation, especially if you're going to publish a report about that audit, is that you've actually verified that it does what it says it does, that it matches the documentation. Like one of the most obvious examples being, do the developers have access to your funds or not? Or is this genuinely like an immutable protocol without custodial control? Can users essentially self-custody their funds in this protocol? Does it meet those demands? And then there's also just general things, unforeseen risks, like, hey, the way you deploy this, the way you might upgrade this, the way the permissions might be managed, are there any risks that the team might not be aware of that need to be raised in the report or that users should be aware of? So for example, you deploy that smart contract today or that code today, but then there's an ability to upgrade it. So we have to add these assumptions into the report to say it's secure, or at least we have done our best to make sure it's secure, assuming this current version of the code. If it's get upgraded, or if one of the roles or permissions are violated, then you might have an issue. So ultimately, we do as much as we can. We usually estimate that code based on the file size or based on how much we see, how much complexity we see, how many integrations we see. But at the end of the day, they're time limited, and we can only find so many bugs. And so what you should do in your team is think about how can we eliminate as many bugs that we can find on our own ahead of time. A lot of that is having testing suites, having documentation, having good comments, and just generally thinking about having an auditor perspective on your own code ahead of time. That way, if there are things that your team couldn't catch on their own, we are able to catch them instead of catching bugs that you could have caught on your own, which ultimately, you're kind of paying for. Each bug is going to have, a certain cost. Even though you're time limited on your audit, you're going to incur a cost in terms of we found this bug, so we can't find this bug if we run out of time. And usually we'll tell you at the end of an audit, do we feel like we've caught everything, or do we feel like we have high confidence, or do we feel like you guys really need to take a closer look at this code and maybe go back to the drawing board, or at the very least consider getting another audit, which is never what you want to hear if you're 2 weeks from release. So 4 stages, these are generally really the 4 stages you should do for any development, but I'm going to put it in the context of audit prep. You should be planning, around the security design and the invariance of your code base. You should be thinking about good practices and tools that you integrate into the development process to catch bugs early on or just prevent them from occurring in the first place. You should have testing. You should be thinking about unit fuzzing and invariant testing, and you should be thinking generally about how are you doing quality assurance, especially at the tail end of all your development, to ensure you're ready for production quality. So, the code early on in the development phase probably won't be, have all of the dots and I's crossed or, basically have comments everywhere or have documentation. But by the time you get close to production, you should. And that is the quality of code that we would expect for an audit that goes well. So planning stage. Before writing any code, ideally start thinking about security in the design very early on. This would be best done by trying to build a threat model, which is really to say, like, what are the conditions under which this code is going to operate? Are we expecting users to be custodying their own funds? Are we expecting this to run on Ethereum, or are we expecting it to run on multiple different EVM networks? Are we expecting this to be essentially pokeable by potentially anyone, or do we expect to have permissions or access restricted? And that helps define not just the conditions under which your developers will then have to build this code to be secure, but also then the conditions under which it will be audited, and for those auditors to then determine, is this code actually going to meet the expectations it will be under? So this is basically going to be your guide for like how you actually develop the code throughout the rest of this process, and what you're testing against and what you're ultimately worried about. And so at this stage, if you're looking at your design and you're looking at your threat model and you see there are certain threats in your threat model your design does not cover well, this is a great time to address them, because if you try to address them later in the development cycle when you've already written the code, that's going to be a much more expensive and lengthy process, and it is going to greatly impact your timeline. And if we're having to address it in the audit, that is going to be even worse. Ideally, we want fixes that we're trying to make at the result of an audit being like, hey, change this line of code, or you correct this issue, not rewrite this entire component because its fundamental design is flawed. So as early as possible, you want to be addressing design issues, and ideally before you've written the code. And as you build it, start thinking about, okay, development. How can you integrate security tooling in your dev process? Is an easy start, like static analyzers on every pull request. For Solidity, general static analyzers like Slither are very common. If you don't want to go through the process of integrating Slither because of some of the compilation steps or other things, OpenZeppelin also has a tool called Code Inspector that kind of tries to minimize it, just reads the source code directly, doesn't worry about compilation, and just, every PR, you'll get a report of like, hey, we found some potential issues, we'll rank them by severity level. Keep in mind, there will be false positives. That's just going to be part of the process, depending on your code. So this generally just integrates a process by which your developers will consistently be thinking about, like, is this a bug or is it not? So even if you get false positives, at least it's forcing your team to think about it. But as time goes on, you should be like tweaking your tooling, restricting bugs that come up recurringly and putting them in kind of like an ignore list, as long as you are keeping a close eye on that and managing it carefully. And in some cases, if it's either not code or it's not a common framework that there's a good tool for, like, consider building your own static analyzer using SemGrep or some other tool that is generally able to run on source code and just detect any patterns that you might be able to catch with a what is it called, functional expression, but basically just looking for common patterns in your code. So as much as you can do, integrate that, but in general in development, just also thinking about best practices. Use common libraries like OpenZeppelin, but also thinking about libraries that encourage best practices in the front end and back end code as well, managing your keys safely, and just a lot of other things that will ultimately come up. At the testing stage, you're going to want to write as many unit tests as possible once you've gotten to a point that you have code that has been developed to the point where you can test behavior. And I could talk about test-driven development, but in practice, most people will usually be doing it after the fact. Figure out what works for your team. Ultimately, at the end of the day, you should just have code that is able to be tested when it's being merged into the main branch, ideally. So not only will you deliver your initial feature with tests, but also if you deliver other features that interact with that feature or otherwise impact the code, you can then further test if the behaviors are still holding true. So unit tests are very useful on the initial stage, but you definitely want to have it as you recurringly change the code base or introduce new changes. And beyond that, there's very good tooling, especially in the Solidity Ethereum space, for fuzzing, where you're basically just throwing a lot of stuff at a function to see what breaks it. And there's a lot of ways that you can do that with Foundry. I have a small little test example up there, but every other like good Foundry example would have taken up the whole screen. But just generally, like, it's a great tool, has a lot of things. Hardhat's also a very good tool for testing. Doing fork simulations, especially if you're going to deploy something into production that depends on some existing contract that's been deployed, or if you're upgrading an existing contract, you might make assumptions about how that contract will operate in production, but that interface or what you've written as a kind of mock in your code base might not match what's actually in production. So you want to test against the real life conditions as much as possible. So fork simulations are a great way to do that. And then finally, invariant testing, going back to like what you found in your threat model, you can usually translate that into invariants that can also be integrated into your testing suite. If you want to go really far, you could do formal verification, but I would say that's for very specific cases where you feel like you are willing to invest a lot into that tooling and that stack. In reality, most teams should be starting with unit tests and working their way up to fuzzing and fork simulations and finally invariant testing, and then eventually maybe think about formal verification. But generally, you're eliminating bugs. That's the main task. But also for auditors, you actually know what the behavior should be. You know what the tests have been written to do. And so the auditors know, okay, what have you not checked against? Now, we won't usually make a full assumption that the tests are working perfectly, because, of course, you could say, I tested this, and then what you're actually testing in the body of that test might be completely nonsense. So it's not that auditors will take it on face value, but it will at least inform them what you expect the code to do for the most part. And it's just a good signal that you're taking your code quality seriously. If we see a code base that doesn't have any unit tests, we are automatically going to assume that there's going to be a lot more bugs per line of code than a code base that does. And that is going to affect the final price. It's going to affect your timeline. And it's generally going to affect whether we maybe work with you versus a project that has done that work and is in that same slot. Because at least for us as Open Zeppelin, but I know it's the case for many other audit firms, we prefer to work with teams that are taking security seriously and are likely not going to get hacked, because we are taking a reputational risk when we work with teams. And generally speaking, this is also something you want to signal to your developer or your community or people that are going to be using your protocol that you are also taking it seriously, and people will usually call you out for this. Finally, quality assurance stage, which this is all quality assurance. So when I say QA, I just mean before you're going to production, you are dotting your I's and crossing your T's. Ideally, you're writing comments as soon as possible, but before you go to production, you're actually writing clean comments. In the case of Solidity, you can even write them in NAT spec, so you actually are including them in the code with specific modifiers so that it can be generated in documentation such as this, which is based on the Open Zeppelin contracts library using a tool called DocGen. And so what you can do is you can say, hey, this is what we expect the function to do. This is what we expect the parameters to do. But you can also put little important notices in here, such as like, hey, if you're going to allow someone, if you're approving an allowance, be very careful about this particular race condition. It can come up. This is especially important if you have a library or if you have a protocol that expects to be integrated with externally or just be called publicly by other developers. You just want to be very, very clear about what the edge cases are and put it directly into the code. And this way, it will pop up not just on our documentation, but it'll also be in the code when people pull it up on Etherscan or whatever public source it might be available on. System of documentation, just broadly speaking, how is your code going to operate? Is it going to operate with these sorts, with these components at a high level? Is it going to integrate with external dependencies? Like it's going to work with Uniswap, it's going to work with Compound, it's going to be part of the DeFi composable stack. You want to be very clear about what the large context of the system is, because then that also gives auditors, view of this documentation, okay, this is how we expect it to operate. Other basic stuff, error handling, logging on all state changes, which in the case of Solidity is just omitting events when you have a state change, and then having access control defined with least privilege principles. Ideally, don't make a single key the admin for your entire account, and for the love of God, don't make it an immutable role. So think about like, okay, how do I make sure that if you have to do a key rotation, or if you have potential loss of key, you defined privileges that have allowed that to be divided using multisigs, having high signing thresholds. Because usually what we do in our audits is we have to assume, we'll point to whatever these roles are and say, we assume that this role is going to be managed appropriately. And if you haven't defined your access control ahead of time in a way that we can review, then we're going to have to just assume you'll use it safely and tell you use it safely. And I'm sure we'd give you very good recommendations about how. But if you define that access control ahead of time and you've told us this is how the multi-sig will be set up, or these are how our roles and permissions are going to be maintained, we can give you more actionable feedback on whether you have met the criteria of what we would call best practice, or if there's more you should do incorrect. Because we see a lot of security incidents today that are not about the smart contract code. It was fine, but someone lost access to a key or they got phished, and the impact was massive and caused large loss of funds. So that's still a big area where you can potentially lose out. So if you include it in the scope, or you at least make it easy for auditors to review, we can review it. Otherwise, we're just going to have to assume that you know what you're doing and encourage you to make sure you know as well. So finally, talking about actual audit prep in terms of like your leading up to the audit, or rather, how should you be preparing specifically for that? The first thing we would always recommend is contacting security vendors as early as possible. I would say 3 months before you expect it to be code complete is a good minimum to ensure availability. Now, this availability will depend on which security vendors you're going to work with, what their availability looks like. Ideally, you should contact multiple and shop around a bit. Don't tell my sales team I told you this, but you should probably be looking at multiple vendors because they might have different capabilities, they might have different timelines, and of course, just cost is a factor. But just making sure you're doing it early, because you never want to be in a rush and coming to a vendor and saying, I have to launch in 2 weeks, who do you have? Because sometimes the audit itself might take longer than 2 weeks, much less the fixed review and other things that might come up. So if you're scheduling ahead of time, that's perfect. 3 months or more is my general benchmark. And then, of course, the market dynamics matter. So maybe ask around even earlier than that to see what audit timelines look like. But then once you've started that conversation, what you want to do is provide as much information up front to do a good estimate. Hey, this is what the code base looks like. Here's all the documentation we have. Here's the expected line count. Here's the timeline that we're looking at when we want to launch. That is going to give us as much information as possible to know what will suit your needs. It is nice to have a code base that is mostly done, but if we're talking about 3 months out or more, that might not be a code base that is done. So what we can do usually is say, hey, what are you roughly expecting in terms of the lines of code? If you have a lot of documentation on what you're building, we can probably look at that and say, we've seen that sort of a staking framework before, or we've seen that sort of a DeFi protocol before. Like, we can roughly estimate what this will likely take and then reassess closer to the start date. And then, finally, doing internal security review, like actually once you've finished all the features and you've done all the testing and you've done all the changes, like actually just maybe spending your own internal review and setting aside time for the team to think through the code and think, if I was the auditor that's probably going to be looking at this in a couple of weeks, how would I break it? Because if you can find those bugs and patch them, that's going to save more time for us to look again at the bugs that your team might not find. And we're also going to be able to give you a cleaner bill of health. Like whenever we see a code base that comes out with multiple criticals, we're going to question the capability of that code and the maturity of that code to actually go to production. And we're probably going to state as much in the report. Versus if we see a code base where there's no criticals and there's no highs, we could only find mediums, and we know that we had enough time to look at it, we're going to feel much more comfortable. Again, we don't usually say you can deploy or you can't deploy, but we'll recommend, do we feel like you're ready? Do we feel like we might have caught everything? It's never a guarantee, but there's definitely different levels of confidence that you might get. And then finally, just freezing the code to the final frozen commit. This can be challenging if this is a big code base where you're not just freezing your development timeline or sitting around for 3 months, or 3 or 4 weeks while the audit completes. But ideally, at least setting aside a frozen commit, and then as you work on potential other features, you are thinking carefully about how that might impact the final code base, or maybe you're saying this is going to come in a later release that gets audited separately. But generally, just having a very code that's frozen as much as possible with a clear git commit to point to say this is the snapshot in time that we are auditing, and making sure that that's available to the auditors. Ideally, a week ahead of time. We'll work with you depending on a few days here, a few days there. But if it's literally the day before and you're still, you're working on a Sunday before the Monday start date to add in changes, especially if they're feature changes, that just usually means that the code's not going to be as mature as we'd otherwise like. So just having some lead space and giving your team some buffer time to have that code as ready as possible and in a frozen state. This is just an example of what your typical audit timeline might look like. Prior to the kickoff, again, we'll do all this, we'll review your final commit, we'll make estimation adjustments if necessary, but generally just trying to make sure that we have all the information prepared. And then once the audit starts, usually, we'll take a day or two with the research team to review the code. We'll do a kickoff meeting. We'll have your team walk us through the code, kind of explain what you're trying to do, explain what you're worried about, and then we'll have questions usually the researchers have prepared after having looked at the code for at least a day or two, and generally walk through it. This might not be the only meeting we hold, but this is definitely usually like a critical meeting we have at the start of the audit to just set expectations, get everyone familiar with each other, say, these are the guys on your team you should talk to. And then once you start that process, having a communication channel where you can constantly be asking questions, or even just asking like, hey, what did you intend here? Is this expected behavior? And then having a team that is prepared to answer those questions promptly, be as specific as possible, and then possibly just hop on calls here and there if needed, if it's easier to just walk through in a live scenario or in a live call. Finally, we'll have an initial report we'll deliver to you. We'll usually list all the issues we found. We'll have suggested changes. In some cases, we might, if it's a long audit time or if it's going to involve, if we see code that might currently be live, we might share issues with you ahead of that initial report. But usually, at least with us, although other audit firms have different processes, we like to gather everything in the context of where it's at and give you kind of a final report so that all of the context and all of the details has been prepared. Our teams internally review these issues and we all feel confident about the severity level being fair, about the edge cases having been covered, and then submit it in one big batch at the end saying, here's all the issues we found. And then once that stage starts, team reviews it. If we need be, we can also walk on a call to walk through it. But generally, they look through the issues. They say, we're going to fix this. We're going to fix that. This, we'll acknowledge it, but this is an edge case. We don't actually think we'll have to address it, but at least providing a comment of why, and then even maybe partially addressing some issues, because some issues might not be able to be completely resolved, but you can resolve it enough to not be an issue in production, or at least something that isn't going to be an immediate thing, but maybe something you keep an eye on, like as an edge case. Usually 1 week is the time it takes for this turnaround, but it depends on just how many issues came up, how big the code base is, what your team availability is. But generally, making sure they have availability to do it as quickly as possible is ideal. And then finally, we'll update the report. We'll include all the fixes, all the issues. We have like a final clean commit that says, hey, this is everything that's been fixed, including all the PRs and things that might have been submitted. Oh, and by the way, in terms of completion, mostly it's just going to be you answering all questions, we have walkthroughs, you have the initial report, and then doing fixes, individual PRs. So each issue should ideally be an individual commit or PR, so that if you're trying to fix 5 issues all at once in one commit, it's going to be really hard to give you proper feedback on all of them. It's like, okay, maybe these 2 were fixed, but then these 2 weren't. And so generally having them be segregated, because then if you're waiting for our go-ahead to merge them into the main code base, you can kind of take it one at a time, and just generally it's going to be a cleaner process, especially if those things have to be referred back to later on to know what was fixed and where, if someone's reading that public report and then looking at the Git log. And then finally, read the conclusion from the auditors, or even ask them directly what their feedback was. Like, how do you feel? Do you feel like we got everything? Do you feel like we're ready for production? Sometimes auditors will be a little bit coy about this. They'll be like, well, we did our best. We looked for as many, we found the bugs we found, but if you ask for our honest feedback, we'll always give it. And in terms of do we feel like you're ready for production, or do we feel like we've done our best, or do we feel like, you should have spent more time on this code base, and that we're a little worried about maybe you going to production. Now, usually there'll be a conclusion in the report that kind of alludes to that, but I think always having a frank conversation directly is going to be valuable, especially if this is an ongoing relationship you want to have. Because if the auditors feel comfortable with the approach, that's not a guarantee that you're good, but you can usually tell a big difference between an auditor that's happy with the result and not. If you have a critical in your code base, or at least a lot of issues more than you were expecting, then that is a good time to at least assess and make sure that you feel good about going to production, or if this should take more time. Okay, so key takeaways, again, lots of text, but really it's down to building a threat model early on is going to make your life a lot easier, especially in terms of setting expectations and having things to test against and guide your security process throughout. Using security tooling and testing will automate the process of detecting bugs, again, reducing the amount of bugs that end up in the final audit. Having time for your team internally to review your code base for bugs is also going to be very valuable. It's something that can be difficult to do if you're trying to hit a timeline, you're trying to put out new features, but it will make a big difference in terms of the code base that is getting audited and the value of the audit itself. Provide as much clarity to external reviewers as possible, and there are obviously reasons to do this for anyone who's developing or using the code base, but for your auditors especially, there's going to be it really reduces the number of questions we have to ask if we can just look at the documentation, we can look at the comments, we can look at the external dependencies that you've stated, and we know what you are intending to do. And then we can ask questions more around the edges of where issues might arise, as opposed to just asking things that should otherwise have been obvious at the start. And then reach out again early about plans, plan ahead to ensure availability, work diligently to provide as much information as possible to get better estimates, to get better, I would say, expectations of result, which is just to say, if you give us a code base that doubles in size, 2 weeks before the audit starts, then we're probably going to want to increase the timeline. And that's going to be very challenging to do usually if there's already a backlog of work that stretches out a few months. That's never a fun situation to be in. So if you think your code base could double in size to where it is today that we're estimating on, then let us know. And if for some reason that your code base ends up not being as big as you initially expected, we can always revise that time down. Just make sure you set that expectation with the auditor ahead of time to say, hey, this is roughly the lines of code we expect, but if it's going to be any 500 lines of code shorter than we initially expected, we can shave off that time. We can usually work with you on that as long as those expectations are set ahead of time. And then finally, read the report thoroughly, submit your fixes in an organized manner, don't introduce other changes in that process outside of what's important to fix the bugs, and that makes sure we have complete coverage. Final thing to leave with is there's an audit readiness guide opens up and put together for clients. It goes into these issues in more detail as well, so that's a good thing to refer to. And if you want to contact me specifically, I leave a Twitter, Telegram there, as well as the Opens Up on website.